Hi guys, welcome to week 3, live lesson 5. This is the live lesson that occurred on Tuesday or Wednesday, depending on what period you're in. Again, if you were not in that live lesson, this is the recorded version and you are required to complete this. This week we are thinking scientifically about how to solve problems, answer questions, or phenomena. So something that we started last week, we're just taking it even further and making it more applicable. So some of my announcements and reminders, please make sure that you're checking the assignments that you've done in previous weeks for grades, for comments, for questions. I am really trying to give you as much feedback as possible. So please make sure that you're checking that out and making sure that like if I ask you to change something and to fix it to make it better, go back and do it and you get full credit. We are going to be following the 2 mutes and a boot whenever you come back to your live lesson, and we're making sure to keep our expectations of being safe, being responsible, being respectful, being prepared, and being here. We are moving into team chats, and whenever you come back, we'll practice that. Thank you guys for your great work to start off the year. Let's jump into the lesson today. So what I would like you to do for your warm-up is to use one word to describe how your long weekend was. Mine was, it's so easy to say fun, but it was like a blast and it was beautiful outside. All right, so today we're going to talk about the scientific method again. You should have done the See, Think, Wonder in our last live lesson video. So for live lesson 4, we did a See, Think, Wonder with the beginning of a video about the scientific method. Then you watched that video again and the second half of that video and took some notes. So the Edpuzzle guided you where to take notes, and then you had a template to fill out the notes. Or you could have written it on your own piece of paper and just uploaded it. If you've not done that yet, you definitely will want to do that. So there are 6 steps to our scientific method. We have observation, research, hypothesis, experiment, conclusion, and then sharing out your results. Now, it appears that they go in a straight line, but these arrows suggest that actually there's kind of a lot of cyclical processes going on here, and that it doesn't always go in a straight line. And even that it might suggest that it's a continuous process, meaning that even if you get to the end, there's always a way that you might go back to the beginning. A lot of time in science, any question that gets answered or any discovery that we have just ends up leading to more and more questions and observations about things we had never seen before. When we talk about observations, the first step of this whole process is when one of your 5 or all of your 5 senses experience something out in the world that is new to you. And that leads you to have some sort of question or thought about something. You next always back this up with research. So you either recall previous information that you have in your brain or use a reliable source to get some background info. You then always want to come up with a hypothesis, and we're not in elementary school anymore talking about an educated guess. A hypothesis is a prediction of what you think is going to happen, and we're going to use this if-then format. If you do something, then this will happen. Because an experiment in science is we want it to be causal. We want it to be a cause and effect. Now, your experiment has a lot of elements to it, and one of them is this idea of your experimental group and your control group. So your experimental group is what you are deliberately making a change to see what will happen. You always want to have a control group that is what it's like if you did normal without any changes, so that any of the changes that happen in the experimental group can be attributed to whatever it is that you change, whatever that variable that you manipulated. The control group then should just be what normal is. You're collecting data during an experiment. So qualitative data is data that is like descriptive, usually using words. Quantitative data is data that is numerical, so using some sort of number or measurement. And then you have your variables. This one is always tough for people to remember, and it just takes a little bit of practice. So the independent variable is the thing that you are purposefully changing in an experiment. It is the thing that you are manipulating to see what happens. It's usually going to be the if that's your independent variable. The then, what happens as a result of that and that you measure is your dependent variable. So if independent variable, then dependent variable. They made a lovely little chart to show how this all goes together, but these are all some key terms that you are going to need to make sure that you're comfortable with. You then want to be able to draw some conclusions from the data. The data might simply tell you that your hypothesis was wrong, and that's a conclusion. It also might point you in some new directions that force you to ask or think about some new problems or questions. And it's always important to share out because whatever you found out, other people might want to know. Now, we want to put this into practice by looking at some real life scenarios and seeing if we can identify these different steps and these different processes in a fun YouTube video. So in our live lesson, we did this as an Edpuzzle Live. We're going to watch this together, pause, answer some questions. It's kind of like an Edpuzzle within an Edpuzzle. I know, it's crazy, but the point of this is that we're practicing identifying some of the steps of the scientific method. The video I chose is super timely right now because of coronavirus, and it is about thinking about why or how germs might spread. All right, so let's get started.
I've always thought if we could somehow just see the germs around us, everyone would be a lot more careful and we'd get sick way less. Unfortunately, that's still not possible, so I did the next best thing by running a day-long experiment in this third grade classroom.
All right, so the first question is, what did this scientist observe, what did this scientist have an observation that kicked off this experiment?
I found this powder called Glow Germ, and just like real germs, when it's on your hands, you can't see it. But unlike real germs, if you turn a black light on, it becomes visible.
All right, so question number 2. How do you think the scientist came up with this idea to use this product? Do you think that the scientist had to do some research? Where do you think he might have done his research?
Transfers to things you've touched, so it provides a really good way to visualize exactly how germs spread. So before the kids arrived, as a control, I went around and noted any pre-existing spots in the room that fluoresced under the black light, and then it was go time. The kids, of course...
All right, so next, what is the purpose again of a control group? And then question number 4, so the scientists did not have a formal hypothesis, but can we come up with a hypothesis? So please use this sentence starter. If the students come into contact with the glow powder, then blank will happen.
Of course, had no idea what we were doing, and that the teacher had been secretly infected with the glowing powder. So she randomly shook the hands of 3 kids, but didn't touch any of the rest. And so with that, they just went about their normal day.
Great. So question number 5, explain what the design of this experiment is. So how did the scientists set it up with who got their hands with the glow powder to start? What did the kids do? How was this experiment set up?
At break, I did choose one random student, and he agreed to letting me put some of the powder on his hands too. And then 2 hours later at lunchtime, I checked the results. Remember, everything you see here started with just the teacher and 1 student having a little of that powder on their hands.
So what was the independent variable in this experiment? Remember, that means what did the scientists change in the experiment on purpose?
And because my flashlight can only illuminate 1 spot at a time, I used Photoshop to better visualize our observations of where germs were left behind, including on the other kids.
So then, what was the dependent variable of the experiment? What were we measuring or evaluating after the experiment was done?
Oh, we're pretty hot over here. Oh, right here. And they were actually pretty diligent about washing their hands. This was the desk of the kid that was infected. And what's crazy is that germs could live on a hard surface like this for up to 9 days. And so you can see how important it is to disinfect the things a sick person regularly touches. For example, this was the phone of the teacher in the experiment. Even if you
So, next question. Do you think that the scientists used qualitative data, so descriptions, or quantitative data in this experiment? Remember, quantitative data are numbers.
Wash your hands really often. If you immediately pull out your phone, a lot of those germs just go right back on your hands. Think about when the last time was that you cleaned your phone. My friend Joanne at the Wall Street Journal recently demonstrated you can clean your phone with an antibacterial wipe every day for at least a year, and it doesn't affect the oleophobic coating at all. And this hopefully gives you a better mental model of why it's really important to wash your hands or use hand sanitizer after being at places like this or this, or this, or this. Cleaning commonly touched surfaces is important because even if a virus is spread through airborne transmission, those tiny droplets don't stay in the air for long. Then they land on surfaces waiting to be touched by our hands. Which raises an important point. The ultimate defense against catching a virus is just don't touch your face. Your eyes, nose, and mouth are like the single weak spot on the Death Star when it comes to viruses. That's the only way they can get in to infect you. But as you can see here, not touching your face is easier said than done. And before you think, yeah, well that's just kids for you, this was what the teacher's face looked like at the end of the day, and she said she tried extra hard to remember not to touch her face. I found this result fascinating, so I put the powder on my own hands for a few hours, and I resisted the urge to touch my face so many times that I fully expected I was going to have a perfectly clean face and the moral high ground. And then this is what I saw. What the heck? I genuinely have no idea when any of this came on. Until I reviewed the footage. Oh, well, there you go. On average, we touch our face 16 times an hour, which is why washing hands is so important. It's impossible to catch a virus directly through your hands. It's as futile as shooting the outer surface of the Death Star. The problem is we use our hands to help the virus out by constantly giving it a ride to our figurative Death Star exhaust ports. Because of this, I ran another experiment with some of the kids after lunch. First, I had them put some lotion on their hands that also glows under a black light. But then I told them I made a mistake and used the wrong lotion. You guys just go wash your hands real quick. Do a good washing, right? Yeah, do the right washing, okay? I just tricked you guys again. Because what I really wanted to do is test how good you are at washing your hands. So guess what I'm gonna do now? Show me your hands. But before I show you how effective...
All right, so he did this little mini experiment, which is kind of fun. I'm excited to see what happened. So what was the design of this mini experiment? What did he do here? What did he test?
If they actually were washing their hands, here's what you should quickly know about viruses. They're super tiny, but also the most abundant biological entity on the planet. In fact, there's over 10 million viruses in any single drop of seawater. And a lot of types of viruses are beneficial to the planet's ecosystem, and only an insanely tiny percentage affect humans at all. And they're really simple. Viruses are basically a shell with some DNA inside, and they just want to spread and duplicate. That's their only goal. But they're so simple that they need a host to do that. So they reproduce by infecting their host cells, and then trick them to become factories that just make more exact copies of the virus. When you get sick and then cough or sneeze, or wipe your nose and then touch a surface, you're putting copies of this virus out to find other hosts, and just repeat the process. And so here's what the kids' hands look like after washing their hands. Uh-oh. Look at the backs. Let me see your fingernails. Oh, look at all those germs. Oh, your thumb. Oh, my hand. Oh, look at your wrist. Look at your wrist. We all sort of have a habitual way of washing our hands. So once again, I tried this myself using the typical quick way I do it in my muscle memory. Granted, that's better than nothing, but you can see the difference compared to when I was deliberate and took 20 seconds. Which is why it helps to do things like sing the happy birthday song twice, or you could do what I do and follow Brandon Flowers' example.
Jealousy turning saints in eager eyes, 'cause I'm Mr. Brightside.
And then for a final experiment, I wanted to show how dumb handshaking is, so I infected the first kid with the powder and then had them do a handshake chain down the line. The fifth person here still had significant traces on their hand, so I put him at the first and lined 4 more kids up after him, and 3 of their hands glowed. So we got trace germs from the original person all the way down 8 handshakes later. So if you ever meet me in real life, please don't be offended if in lieu of a handshake, I offer you a fist bump and a selfie. In conclusion, what does this all mean with regards to the coronavirus COVID-19? You should be concerned and take this seriously, but regardless of what you see in the coming weeks, there's absolutely no need to panic. As I'm sure you've heard a bunch by now, our goal is to flatten the curve so that the reported cases stay just under the capacity of the healthcare system. And social distancing is the best knob that we can turn to affect that. The reason this helps should hopefully make more sense after watching this video, especially for those who have been doubting the science and feeling like this is an extreme reaction. And my take here is I'm a practical optimist. The upside is while this virus is bad, it could be way worse. And this gives us a chance as a global community to get some systems and methods in place to handle something potentially even more drastic in the future. Also, maybe it will lead to changing some social norms, like replacing handshakes with fist bumps, or when people are really sick, thinking it's okay to mingle about and go to work. Globally, the normal flu kills anywhere from 250,000 to 500,000 people a year, due in large part to people not practicing good germ hygiene. So if this experience makes people more socially aware of the right precautions to take when they get sick, that will save countless lives for years to come, long after this coronavirus is old news. I make no mistake.
So, what would you say is the conclusion from all of this, from his main experiment as well as his couple of mini experiments?
This is going to be rough for some more than others, but history has shown that us humans are pretty resilient. These types of things can bring out the worst in us, but they can also bring out the best, most wholesome parts of us, like these Italians practicing their social distancing with an impromptu balcony concert. How we feel about the situation is largely dependent on just which part we choose to focus on. For me, that means being grateful to the heroes in our healthcare system, or the school lunch ladies still providing free lunch for kids who depend on them, or the scientists all over the world who are working tirelessly 7 days a week to create better testing methods and a vaccine. This is going to be a bumpy ride for us.
So, do you think that this is a valid experiment following the scientific method? Why or why not?
But the economy will eventually bounce back, as it always does, and we'll be better off as a global community for having gone through this. Again, take this seriously, but there's absolutely no need to panic. We totally got this.
And finally, share out your two main takeaways or conclusions that you can gather from this experiment. Great. So hopefully before now, you have already done the week, I should say 3, my bad, week 3 preview number 11. You now have a live assignment number 12 that is posted. What it is it will take you, the assignment, it says number 12, Edpuzzle Scientific Method in Practice Choice. Now that we've done one together, you're going to have to practice and identify the steps on your own. So it's going to take you to a slide, and on the slide there are 2 options. You are required to do one, I repeat it, one of the options. You either need to are either going to complete the Edpuzzle that takes you through a very similar process for testing edge control products, or the question, do sharks like human blood or fish blood? Now, you can do both if you would like for some extra credit, or if you're really like finding it to be a fun process. But again, you are only required to do one. Great. Please let me know how you're feeling. And I hope you enjoyed today's lesson. I will maybe see you for the next one. If not, I will see you digitally later when you do the recording or as you work through this week's assignments. Have a great day.